Hello viewers Friday, welcome to IO Codes. In today's video we'll be talking about recursion. So recursion is technically a programming concept, is a very powerful kind of concept that can be used to work on programs. Recursion comes into play where in most cases our traditional for loops and while loop cannot do the job. So recursion makes things a little bit simpler and even makes the runtime of some particular program much more faster. So I did have some little definition of recursion, explaining it at least to some percentage in details, so you'll be able to understand and grab the concept of recursion. So I'll pull up that presentation. Okay, here we have it. So I'll move over to the previous page. Say introduction to recursion, and this is the related definition. So a recursive definition is one that uses the concept or thing that is being defined as part of the definition. For example, an ancestor is either a parent or an ancestor of a parent. Okay, going further, so a sentence can be, among other things, two sentences joined by a conjunction such as and a directory is a part of a disk drive that can hold files and directories. Now this definition right here, directory, really makes really brings what recursion kind of means. So inside of a directory we have a directory, and we can also have files. So there might be cases where we have just directories in a directory, and there might be cases where we don't have any directory, we just have files in those directories. Now defining a directory, in some cases you have to include the word directory. So recursion has to do with something like you are defining something, but defining that thing, you are doing it in terms of itself. Now going further, in mathematics, a set is a collection of elements which can themselves be sets, and a statement in programming can be a while statement which is made up of a while, which is made up of the word while, sorry for that, a boolean value condition and a statement. So you can see even in statements such as while statement, we also have the word while being defined inside of it. So we have to be while, a boolean value condition and a statement. Pretty much you understand what I'm trying to say here, because you stumbling upon this video, I believe you might have one or two things with programming. So move on to the next page. You can see we have more recursion. So recursion can be used as a programming technique. A recursive subroutine is one that calls itself either directly or indirectly. Now to say that a subroutine calls itself directly means that the definition contains a subroutine call statement that calls a subroutine that is being defined. So when you say a subroutine calls itself directly, it means that inside the definition of that subroutine there is a call to the same subroutine that is being defined. And to say that a subroutine calls itself indirectly means that it calls a second subroutine, which in turn calls the first subroutine. So when we have like a subroutine that counts number, and before it counts the number, it prints out that number, and inside of to print out that number, you use another different subroutine or another different logic subroutine in this case to print out that number. But instead of the subroutine that prints out this number before it's being counted, there is also the count method in that subroutine. So this is a kind of advanced concept, and it's just the same with the recursive on recursion. So well, the subroutines we are going to be defining in this video are just simple subroutine directly calls themselves. So this subroutine will be defined in this video in the next section, probably in the exercise we are going to be handling just calls itself directly. So maybe I'll try to give an example of subroutine that calls itself indirectly. So a recursive subroutine can define a complex task in just a few lines. So this is the beauty of recursion. With recursion, we can define a really complex task in just a few lines, and you are going to be seeing this explanation in details. You are going to be seeing the manifestation in detail. Let me put it that way. So let me close this Chrome browser and We're going to jump right into our IntelliJ. Okay, no, for that we don't have our question yet, and there's still more sort of thing. So now, what to take into consideration when using recursion? So we have two different things that should be taken into consideration. From my own point of view, there might be other things, but these two different scenarios, these different concepts is what I really put into consideration when I'm defining a recursive subroutine. So now the base case. The base case is a condition that defines when recursion should stop. It's a condition where the subroutine does not make a recursive call and returns a specific value or performs a specific action. Okay. Without the base case, the recursive subroutine will continue to call itself indefinitely, leading to stack overflow or infinite recursion. So probably the stack overflow is, it gets to a point the computer keeps repeating the same thing due to the absence of a base case, and then the computer will just, or perhaps the compiler for your program will decide to throw an error because it has to get to a point where it stops because of memory and some other stuff. Now, this is also synonymous to infinite recursion, where your code continues to run the same thing over and over and over and over again because there is an absence of the base case. So the base case is one thing that you should take into consideration. So an infinite recursion is more like a while loop that does not have an ending part, an infinite while loop. So just put the condition while something is true, and there's nothing inside the body of the while loop that either breaks out of the while loop or ends the while loop. So this kind of scenario is synonymous to infinite recursion. So therefore, it is crucial to define the base case that terminates the recursion. So when the subroutine calls itself over and over and over again, there's a point it gets to, the base case will kick in, and when that base case kicks in, the recursion will terminate. Now we have problem decomposition. Problem decomposition refers to breaking down a complex problem into smaller, more manageable subproblems. In a recursive subroutine, problem decomposition is achieved through the recursive step. Each recursive call operates on a reduced or modified version of the original problem, bringing it closer to the base case by decomposing the problem into smaller subproblems. The recursive subroutine can solve the original problem by solving these smaller instances. So when you are asked to count 1 to 10, and how you do it, you count 1, and then you count 2. As you can see, you are counting a number at a time. When you count the first number, the number that is remaining for you to count is just 9 numbers. So the number has reduced in a way. So at the very first instance, when we call a recursive subroutine, the very first problem it's about to solve is a problem that is kind of bigger than the problem it will call again within itself. The subroutine call it will call again within itself. So explaining this, you have an idea already of what it is, but without seeing it in practice, without practicalizing it, I guess you won't really understand more details. So for that, we'll be moving over to the next page. We'll be looking at the exercises we are going to be covering in this video. So about the next page, we have exercise 1. It says using a recursive subroutine, write a code that prints out all the values in a given array in the reverse order. That is, the last value in the array should be printed first, while the first value should be printed last. So we have an example explaining in detail. You say array A contains the values 1 to 5, and after applying the subroutine, the values is then printed out on the console as 5, 4, 3, 2, 1. So this exercise we are going to be solving is an exercise that even a traditional loop can solve. So it's nothing that much. Is not a big deal, but I just want to start with something more simpler. Then we'll move over to the next one. Um, this is where we can see recursion coming into manifestation, because in this exercise we are going to be solving something more tangible and something more difficult that even a traditional for loop, I don't think it will be possible, or perhaps even if it's possible, but the algorithm kind of be hard to get. So we have create a binary tree node class to represent nodes in a binary tree. Each node should have a value associated with it. Additionally, I would like you to provide values for each node up to the 10th level of the tree. So if you don't know what a binary tree is, I'll be explaining what a binary tree means, what a binary tree is in more details. Pardon me. Then considering the root node as the starting point of the hierarchy. Now number 2 says write the program to calculate the number of nodes in a binary tree. You are provided with a binary tree node class representing the nodes of the tree. Your task is to implement a function or method that traverses the entire tree and count the total number of nodes present. So perhaps after we've populated our first node in this scenario, we'll populate it up to the 10th level of the tree. Then this program we're also going to use to count the number of nodes in the tree. So it says consider the root node as the starting point of the tree. Your solution should work for any binary tree, including the one you created earlier. So like it stated here, including the one we created earlier. So this is talking about the 10th level, but we want a kind of algorithm that is going to even solve for the 1 billion level of the tree. And perhaps let me give an explanation. Maybe when God created Adam, the first generation, when God created Adam and Eve, so they were just two. So they gave birth to other children, and these children gave birth to other children, and so on and so forth, till we got to this particular generation we are in. So you can see the multiplication from the children of these two persons, Adam and Eve. We went on further to have a multitude of people on earth. Let me put it that way. So I bet let's move to the previous page, and you can just pause the video and try to see if you can come up with an algorithm that pretty much solve this exercise. And when you try your best, and even if you don't come up with an algorithm, is also fine. Then you can come and check out the video. So you can go ahead, pause the video, and when you are done, you can come check out the solution. So let's check out the solution right now. And if you really did pause the video and check out this an algorithm solution yourself, in terms of, so we have a simple algorithm. So the reason for this algorithm is the fact that I'm using a programming language that will be quite different from yours. It doesn't really matter the programming language you are making use of. If you are making use of Python, JavaScript, whatever, what really matters is the algorithm, the lay down step to achieve the particular solution to the answer. So I've written my algorithm. My algorithm is more like the answer, a general answer. Following this algorithm, using in preferred language of your choice, we're also going to arrive at the same solution. Don't forget that programming languages are just tools to solve a particular problem. So different programming languages have different sphere of what they can do to a particular percentage, and different programming languages have what they can do. Let me put it that way. So now a simple algorithm to implement. So we create a new array and assign values to it. Then we create a method called print reverse that prints out the values of an array in reverse order. So that's simple. That's what the question really talked about. Then the method print reverse algorithm. So we are going to provide two parameters to the method. the particular array and the particular index to print will be the parameters that are provided to the method. Now we are going to check if the index is equal to the length of the array, and we will return out of the subroutine. So I included the note here and placed a quote right after it. It said this would be our base case. So it checks at first if the index is equal to the length of the array, and if the index is equal to the length of the array, we can't access an element at that particular index because the index is not equal to the length of the array. So it's going to throw an index array index out of bound because you can't access the length, the value length of an array index. Now we're going to increase the value of the index, and we're going to call print reversed again. You see, we are calling this the algorithm for the print reversed method, but inside of it we are calling print reverse. That's the whole concept of recursion. Then we print at the values at that particular index, then we end the subroutine. So this is just probably you can see the code may not even be as lengthy as it is, but we are going to be implementing everything on this algorithm. So let's jump in right now to our code editor. So I'm right here, my IntelliJ. I'm using IntelliJ. You can use any code editor of your choice. I'll be creating a class. So you all know. I'll call my class print array reversed, and that is it. So let me create a public static void main method, and now just like our algorithm has stated, I'll just reduce the size of this and move it right over here. So let me also reduce this one just to put it on par. Now it says create a new array and assign values to it. So let me create a new array, and that array I'll be populating it with a value of 1 to 20 perhaps, or 1 to 30, and then I'm going to use a for loop to achieve that. So let's just make it short and make it 1 to 10. So this int array, and I'll call it number equals to new int, say 10. That should be the length of the array, and semicolon. Now we have to create our method print reverse. So this should be a static method. I don't want to work with objects at the moment, so let's just make it a static method. So we have public void does not return anything, public static void print reversed, and recall it takes in two parameters. The first parameter is the particular array we are trying to print in the reverse order. So I'm going to say int and number, and then I'm going to specify the index, which is also the type of index. Now recall what we have done to this part. Right now you can see we have implemented to this part. Now we are going to check if the index is equal to the length of the array. So if index equals to number dot length, we are asked to return from the subroutine how do I possibly fail to include double quote sign that checks for equality in Java. Now we are asked to increase the value of the index. So increase the value of the index by saying index plus plus, and then we print out the value at Okay, we'll print out the value at the particular index and say sound number index, and I want to include a space. So there's something I have to point out. Now if I increase the value of index at this port, there would be an error. That's why I was looking at the code. It won't necessarily be an error, but it's not going to print out from the very first value, or perhaps yes, then it's not going to print out from the very first index. So for that, this is what we are going to be doing. Initially the algorithm goes like this, so I'm going to call print reverse before I print out the value at the index. So when I call print reverse, I'm going to include the value of index, yes, and then number alongside, which is our array, separated by a comma, of course. Now as you can see, the index value has been incremented at this point, and going further it is going to affect our program right here because the value of index has changed. So because of that, we are going to remove the whole of this incrementation of index, and then we are going to attach it in the method that calls print reverse again, in the statement that calls print reverse again. So now this is basically it. With this we have defined our recursive subroutine. So you can see we called print reversed inside of print reversed. So at a point when we specify the index we are trying to print from, it gets to a point as this increment continues in each call to print reversed, get to a point that the value of index will definitely be equal to the value of number.net, then it's going to return from that subroutine. So I'm going to populate our array now with the help of a for loop. So I'll say int I equals to 0, I is less than number.length, and I plus plus, and this is just going to be a single statement. So number at I as number at index I equals to I plus 1. The reason for I plus 1 is because at this very first index I is equal to 0, and we want our array to be populated with a value of 1 to 10. So 0 plus 1 is equal to 1, and so on and so forth. Now we are going to call print reverse. First of all, I'm going to say printing out array values in reverse order. I'm going to call print reverse, and then we specify number separated by index should be 0. Or can even go as far as in case there's no need, we are starting from index or 0, so there's no need to assign a variable, or you can also assign a variable assign int r equals to 0. Still going to work either way, just to reduce the line of code. So I think there's no need to just specify a variable for that. So we are starting at index 0, and someone is going to print out all the values in reverse order. So I run the program, and you see for yourself the magic that recursion really does. So I'll expand it right now. Oh. So as you can see, we have an error right here on our screen. This pretty much is Stack Overflow error I was talking about. So the algorithm we laid out, we implemented it properly, but I don't really know the issue behind this stuff. So that at first I paused the video and I decided to check if there was something I was missing, and apparently there was nothing because the algorithm was properly laid out. It was to be followed as instructed. So you can go ahead and implement the algorithm in any programming language you are making use of. So then I discovered that this particular statement right here didn't really increment the value of index. So what I did, instead of incrementing it using this pattern, using double plus and symbol, I incremented it with just +1, and then I ran the program again. So as you can see, we have printing out array values in reverse order, and this is printing out the values in the reverse order that it was being added to the array. So basically, recursion really has to take more of practice. You have to do more of practice, and then with more and more practice, you get used to it. Just check it out now. We also came across the Stack Overflow error, despite this particular exercise being a very simple one that could have also been done, that could have also been carried out with a loop. Still yet we still face the Stack Overflow error. So that's basically recursion for you, and this is quite simple. In the second exercise, we'll see recursion manifest it, the technique that it has to do with input that way. So I want you to do something for yourself as more like practicing and building up on this particular assignment, on this particular exercise we just did. Now we printed out these values in the reverse order. I want you to like reformat this code, and you can decide to change the size of your array to hold up to any desired value of your choice. But this time around, I want you to print out the value using this same print reversed method. All you just have to do is just make a little change, and this time I want you to print the value in ascending order, that is in much more like printing the values out the way it was imputed into it. So instead of 1 being here, we have 10 here and 1, and it's going to start from the very first value that is being imputed in the array. Remember, this is 10, 9, just like the way it came into the array. 10 was the last digit that was imputed into the array, so that's the print reversed. Just write a method. This method should be similar to print reversed, or you can also use print reversed. But this time around, I want the values to be printed 1 to 10. Just take it as an exercise on your own part, and that's it. You just have to refactor this code a little, nothing much. No, don't use a for loop for this. Use recursion. It will make you build up on what you've learned so far. So thanks for watching, and I'd love to see you in the next one. In the next video, we'll be covering binary trees, and we'll be using recursion to work through binary trees. So this video is quite long for a video that just talks on recursion and basically did a simple exercise. So in the next video, I believe it will be short because we've just been talking about just one concept, and we'll be doing the exercise building on the concept of recursion we've learned in this video. So keep your eyes peeled, and I want to catch you there. Okay, see you. Peace out. Don't forget, subscribe to the channel, ping the notification bell, and so give me a thumbs up. Peace out. Thank you.